Hello students, this is Anjana from Computer Science Department. In this class, we are going to discuss about domains and interfaces testing. So now let's get into our topic. So now let us see what is a domain testing. Now let us see about the domain testing strategy. A domain testing strategy is the thing. Before performing a domain testing, we need some strategy about the domain testing. Now let us see what is the strategy of the domain test. Here, the domain testing strategy is simple, although it is very simple, but although it is possibly tedious. Tedious means it is very slow. Slow means without being fast, it is becoming very slow. So the domains are defined by the boundaries. Therefore, the domain testing concentrated on the test points on the near boundaries. So we can classify what can go wrong with that boundaries. Then we can define whatever the test strategy, whatever the strategy. Then we should want to define the test strategy. We should want to derive the test strategy. Therefore, the domain testing concentrated on the test points on the near boundaries. So we are having some boundaries for a domain. So whenever you are going to test that points on the domain, then only you can easily achieve the domain testing points such that it will be very near to the boundaries, so that we can classify what can go wrong with the boundaries. Then we can define the test strategy for each case. So for each and every case we are having some test strategies. So based upon the test points or near boundaries, we are going to pick that boundaries. So we can classify what can go wrong with the boundaries, then define a test strategy for each case, then pick enough points to test for all recognized kinds of boundary errors. So for a boundary you are having some test points. Now for you have to check whether each and every test points and pick up those points, and you can recognize that whether it is having some boundary errors or not. Why? Because each and every boundary serves at least two different domains. Okay, each and every boundary serves at least two different domains. The test points are used to check one domain and can also be used to check the adjacent domains. So what are the adjacent domains? Adjacent domains is side by side domains here. What are the side by side domains are here? We are going to check that, and again it is going to remove the redundant test points. What are the redundant test points? It is not a basic thing. It is not a redundant. It is a redundant test points. Then you have to mainly focuses on the redundant test points. Then after that, after performing the testing, then actually you have to run the test, and we have to protest that analysis. That is a very slow part. Tedious means we have already said that it is a slow part. And again we have to determine if any boundaries are faulty, and if so, how. Okay, however, if it is so faulty or not. And next one, it run enough tests to verify every boundary of every domain. So you can run the test of the every boundary with the every domain, so that each and every boundary have some faulty tests. So we can determine it by using you can run the test and to verify the every boundary of the every domain. So uh, before doing the domain testing, what is the domain testing strategy is here. The domain testing strategy is simple, and all it is possibly tedious. So the domains are defined by their boundaries. Therefore the domain testing concentrates on the test points or in the near boundaries. So we can classify what can go wrong with the boundaries, and then define the test strategy for each case, and we can pick the enough points to test for all recognized kind of boundary errors. Why? Because every boundary serves at least two different domains. Test points used to check one domain can be used to check the adjacent domains, such that we can remove the redundant test points. So we can run the tests, and by process analysis we can determine if any boundaries are faulty, and if so, how. So we can run tests to verify the boundary of the every domain. Okay. if you observe this domain bugs, then first of all you came to know that what are the domain bugs and how we can test for them. See, in the next slide we are going to show one figure. So what are the points inside the domain? We can say it as interior points. What are the points that are outside the domains? We can say it as a extreme point. So here the interior point is a point in the domain such that all the points within the arbitrary small distance. So if it is within the small distance inside the domain, it is having just like that, we can say it as a ellipse and neighborhood. Okay, with just like neighbors with small distance, all the points are within the domain, then we can say it as the interior those points are interior points, and it should be also in the domain. So next one, a boundary point is one such that within the ellipse and neighborhood, there are points both in the domain and not in the domain. So there are the points which are in the domain and not in the domain. We can say it as a boundary point in such that within the ellipse and neighborhood, that are the points both in the domain and not in the domain. So an extreme point is a point that does not lie between any two other arbitrary but the distant points of the convex or a domain. So if you observe these things, whenever a domain bugs, if you are going to observe a domain bugs, how to test for them and all. See, basically a domain is a thing which we can easily test, but if you can find the interior point which is very close to each other, that is just like a ellipse and neighborhood. So if those are very close to each other, then we can say it as an interior points. Okay, for that interior points we can easily test that interior points. Why? Because if each are interconnected to each other just like a neighborhood. But when it comes to extreme point, extreme point is completely different, that it does not lie between any two other arbitrary points, and the distance it is totally out of the domain, and the distance between any two points in the out of the domain, that is difference between any two extreme points is very far. But when it comes to a interior points in the domain, the distance between the two points is very near, that is not a far, that is near such that we can the distance is very near, so so that we can test it very easily. But here in exterior point, a boundary point is one such that within the ellipse and neighborhood there are the points both in the domain and not in the domain, so such that an extreme point is a point that does not lie between any two other arbitrary but distinct points on the convex domain. Okay, so this is how we are going to find out the domain bugs. So now let us see this next figure. So this is the interior point which lies inside the domain. So this is the extreme point which is at the outside of the domain. It is in the boundary. This point is the boundary. So we can say it as a boundary point. So for this interior point, these are the neighborhoods, ellipse and neighborhoods. Okay. So in this figure, we are going here we are showing the interior point, extreme point, and about the boundary point also we have seen. Okay, see, if you observe the practically, if you have observed this difference, see in this domain we are placing some path of items such that if you want, why we are grouping the items means, if you are grouping like that, then only for the person who is going to test that particular code, he will be very easy for that to identify. Without grouping, how he can identify that thing? So that is not a that much easy task to perform. So on one point on the boundary, he has to focus first of all whether it is in the boundary or it is not in the boundary. So first, before entering into the domain, he has to check for the boundary point. Okay, if it is in the boundary, if it is a point in the boundary, he has to check. If it is not, he can come to the another point. But if it is having boundary point, he has to test that boundary point whether it is having any arbitrary neighborhoods or not, and it is associated with any point or not, and it is having any errors or bugs or not. He has to check all these things. After arising all these consequences itself, he can go for the next extreme point. So this is not a that much easy task, we can say. But when it comes to in software testing, why we have already said that why you have compared these domains and paths means, uh, uh, by organizing the data just like a domain, then only for a particular software tester he can easily test that software programming very easily, such that he can do the programming much better. So without testing the software, he can't able to. Without testing that software, he can't able to run that software also. Yes or no? Without testing that software, he can't able to run that software also. Then how he can do that particular kind of. Then how he can do that particular kind of testing? So from this we can say that that is not an efficient task for that particular user. He can't able to move that data just like that. And next one, if he is that much interested in performing the task like testing, he should not he not he that he is not he not able to do the he must not able to do the task like that. Why? Because if he is interested to do the task, he can go for the domain, he can go for the task called domain testing like that. So whatever the point is not a matter, where the point lies is the matter. So he has to check for the uh, boundary point, extreme point, and interior point. So before entering into the domain, if he knows about the boundary point, he has to test that boundary point. He has to test for what? Whether it is lying between, whether it is lying between any neighborhood points or not. If it is having immediate neighbors, you have to check for that one also, and you have to test for that one also. If it is having immediate neighbors, he has to check whether it is a uh, extreme point or interior point or boundary point. If it is the boundary point, along with this boundary point he has to check. If it is not an boundary point, then when you are testing for the extreme point, at that time we can test. Okay, first of all, that one we have to see. And next we have to see about the extreme point. See, at that extreme point also we'll see where it is lying here, and with that how many neighborhood points are there. So if it is having another extreme neighborhood point, it can go for the another thing. Otherwise it can be done very slowly. It's not a difficult task for it. So an on point is a point on the boundary if the domain boundary is closed, but off point is a point near the boundary within the but in the adjacent domains. So whatever, when the boundary is open, an off point is a point near the boundary, but in the domain it is being tested. Okay, but if you remember that closed off outside and open off inside technique, the domain boundary is closed and off point is near the boundary but in the adjacent domain. Okay, but if the boundary is open, then the off point is near to the boundary but in the domain is being tested. And you can remember this one COOI, that is closed off and outside and closed open off inside. So now let's go for this. So this is the thing. So if you observe this on points and off points here, this is the boundary. On the boundary you are having here, this is the two cross lines, this is the extreme point. So this is These are outside the boundaries, so we can say these are as the off points. So this is inside the boundary. These are on the boundary actually. All these are two are boundary points and one is extreme point. Okay. So these are on points. Though the points who lies on the boundary, we can say it as on points. The points which is not which is not staying on the domains, we can say it as a off points. See, it is showing the domain bugs and the closure bug, and about the shifted boundaries and title boundaries, extra boundaries. What are the title boundaries? What are the extra boundaries? And what are the missing boundaries? Here it is showing that one. So if you observe the key point here, what is a generic domain bug? So if the generic domain bug arises, it can show where it can be where it can be shown, such that the closure bug will be a shifted boundary and it will be a title boundary. And in this figure, we can bifurcate just like how what is the mixed boundary. But here, why all these points is coming to picture is sometimes at a time the multiple access may happen, such that at that time it may be a have it we if we are having the chance to get ambiguity. So by without getting the chance of ambiguity, we can we can easily erase that erase that topic, and we can easily solve that particular kind of data, and such that the extra boundaries and missing boundaries are not being saved. So such that the on points and off points, if you observe on the domain, so if you observe that on points and off points, the points who lies on the which lies on the boundaries, and in between the boundaries, that is extreme point, so we can say it as a on points. Okay. And next one is the points which are not in the boundaries, the points which are not in the boundaries, and it is not staying on the boundaries, we can say it as off points. Why it is called off points? Because literally we can say that it does not related to any kind of it does not related to any kind of the thing, such that it is not be used by the other user, and it may not showing any effect on this data. Okay, it is not showing any effect on this data, such that whenever you are going to perform the testing, it is not that much easy to perform the testing just like that. Okay, this is the on point and this is the off point. Again I am saying uh, the points which are lying the points which are lying on the points which are lying on the boundary, we can say it as on points. Which are not lying in the boundary, we can say it as a off point. Okay, so by observing all these differences, we can easily say that it is not that much easy to find out the on and off points. Why? Because if it is a strange thing, then it is very difficult for that user to find out the points. So for that, he has to it has become stopped. So these are about the on point and off point. So now let us see what are the next. So if you observe that this is a shifted boundary. Okay, this is a shifted boundary. If this boundary dot boundary is shifted to this line boundary, then we can say it as the shifted boundaries. If the boundaries this see if this portion is shifted to this side, this portion is shifted just like that, then we can say it as a shifted boundaries. Okay, if the boundary is like this is open and this is to close. Okay, we can say it as a titled boundaries. Okay, We can say this one as a titled boundaries. So this one is open or closed error. To identify the error and to show the errors, we have to draw like this. So we can say it as a open or close error. So this refers to correct and this refers to incorrect. Okay, if it is incorrect, it is shifting from one place to another place. This is in case of incorrect boundaries. This is in case of correct boundaries. Okay, this is also like that. Okay, this is in case of incorrect boundaries. This is in the case of correct boundaries. Okay, so if it is extra boundary, just like that, we are going to draw like this. This is the correct boundary and this is the incorrect boundary. Now let us see what is the missing boundary here. So if you have drawn like this, if you are not able to find other boundary, then we can say it as a missing boundary. So these are the generic domain bugs that we are going to erase while we are perform the domain testing. So whenever we are going to perform the testing one dimensional domain, so the closure can be a wrong such that that is assigned to be a wrong domain. So okay, we'll discuss this testing about the one dimensional domain in the next class. Okay.